Have you ever wanted to solve one of these guys? Well, with a little trick, I'm going to show you how it's done. I'm not actually going to teach you how to solve a Rubik's Cube, but what I am going to tell you about is God's number and how God's number can be found. For any Rubik's Cube, it is theorized that there is a number, God's number, that for however scrambled it is, you can return it to its solved state in n amount of moves, also known as God's number. So two Rubik's Cubes with completely different random states, if God's number is, let's say, 30, you could return it to its origin in 30 moves. Finding God's number is kind of difficult. For one, think about how many possibilities there are in a Rubik's Cube. You have 8 corners, which each can be oriented 3 different ways. You also have 12 edge pieces, which can be oriented 2 different ways. You can ignore the center pieces because they are static, they never move. So how do we navigate all the different possibilities for every single permutation of a Rubik's Cube to find out how many moves we need to make to return to the solved state every time? We're going to use a special algorithm called Korf's algorithm, also known as iterative depth A-star search. Korf's algorithm combines depth first search and breadth first search to find the optimal amount of moves to solve any Rubik's Cube from an initial random state. The way Korf's algorithm works is like this. You take a random state, and then you make one move away from the initial state. So for an actual Rubik's Cube, there's not just 2 options, there's 18. You can go like this, you can go like this. There's 18 different ways you can manipulate the cube. Then, at the next node, you also move one away from the origin. And you continue for each possibility. If any node has a path length longer than the worst case scenario that we've put in, then we can eliminate it and we don't have to calculate it anymore. The worst case scenario is something we can do to estimate how long it's going to take. So, for example, I know I can solve Rubik's Cube in 50 moves. So I'm going to say if any of these are worse than 50 moves, we don't need to calculate them anymore. So this is a really efficient way for finding the most optimal solution to a Rubik's Cube because it runs in linear time and not exponential time. And it also has halts. So when we know something is greater than 50, then we can stop counting it instead of going down that line forever. So we don't actually need to traverse every single possibility, but only the ones that are going to have path lengths less than the worst case value. Using straight up Korf's algorithm though is still incredibly expensive if we want to just traverse all the solutions that are going to get us to a solved state. What we're going to actually end up wanting to do is break down the cube into a set of simpler problems that are smaller. The first thing we're going to want to do is just look at the edges. So the Rubik's Cube has 8 edges, as mentioned earlier. With the edges, we know that there are 8 times 3 to the 7th possibilities. Because it's not 3 to the 8th, because the position of the last cube is determined by the other 7. So, if we can use Korf's algorithm only on the corner pieces and find the least amount of moves to get to a state where all the corners are in their correct position, then we are going to have the basis for the larger problem. We do the same thing with edges. We take each of the edges and the amount of possible combinations for getting the edges in the right places is equal to 12 factorial times 2 factorial divided by 2 factorial times 6 factorial. So these are much, much smaller numbers than what we're dealing with even the best case for Korf's algorithm. So what we do is we compute the optimal path lengths for just the edges. Then we compute the optimal path lengths for just the corners, and then we find the intersection to see where the move sequences are equal to one another. Once we do that, we can find God's number. So where the improvements are in God's number and how we got from a really high value, it started at 56 in 1980, is we continue to do this, we continue to revise our hypothesis, and as computers get more and more powerful, they are going to be able to crunch more and more numbers. So we start out at something like 25, we realize that all the paths can go under 25, so we can go down to 24, and we continue. Another cool thing about this is we know God's number now has a range of 0, meaning the lower bound and the upper bound for God's number is 20, meaning every single cube can be solved in 20 moves. Before, we had lower estimates, so in 1980, again, our lower bound was 18. We knew we could solve some cubes in as few as 18 moves, but we did not know if there was cubes that were complex enough or scrambled enough that they would take 56 moves. We've gradually narrowed it down all the way into 20. So, now you know how to use graph theory to find the God's number, or the optimal path length to get from a scrambled cube to a solved cube. Thank you. Just one trick. You can solve a Rubik's Cube.